Okay, we're going to take a look at a very important function. It's called a quadratic function. And so it is the function f of x equals x squared. Now that's the base function, but it can be shifted around, it can be stretched, it can be compressed. We saw transformations before. So there's a lot that can be done to this. But the shape that it makes is called a parabola. Now we can have, it's the smiley face, or sometimes they're upside down, and we can have the frown. So the first thing they're asking us here is to find the vertex, which is this point at which it rests on. And so the vertex here is going to be the point 3, 1. So that is just where that U is centered on, right there. Okay, now the axis of symmetry is the vertical line on which it's symmetrical. Like you could fold it over this line and you'd get the same thing on either side. Well, that's always going to be a vertical line, and the vertical line is always going to be x equals, because vertical lines are x equals, and the x value is 3. Okay? So x is 3 would be the axis of symmetry. If you fold it over the line x equals 3, it's the same on either side. Now we could find the zeros, which would be where it hits the x-axis, the x-intercepts. There aren't any on this particular one. And the y-intercept would be the point 0, 7. Alright, now this is very confusing, but you can have the general form of what's called this quadratic function, and it's just going to be a polynomial function. It's just going down, x squared, x, and then any numbers. Or you can have what's called the standard form. And this standard form, which I'm going to skip over this for right now, but this is a really important version. This version of the quadratic is the transformation. It shows you any right shift, it shows you anything up or down, and it shows any kind of vertical stretch. I may need to come back to this slide. Let's see here. What are they asking? Okay, so they're asking this to be written, hold on, in the general form? Oh, I see what they're doing. Okay, so when they're asking this question, the standard form is the place to start, because we can make that equation just off the shifts. We went back, so here's the vertex. It's been moved back 2. Okay, well, moving back 2 would look like this, and then it moved down 3. Okay, let's see, are they doing what I think they're doing? Yeah, this is not the greatest question. All right, so I want to make an equation for this quadratic function. I've gone back 2 and I've gone down 3. Now here's the only problem. We don't know whether or not there was any kind of stretch or compression on this. So I've added an A in front of here because I'm not sure if there was a stretch or compression, and nothing here easily tells me. So I have the function, but I don't have that stretch factor. Well, all you need is a single point off the graph. Just like you did if you were doing y equals 3x plus b, but you didn't know b, if you had a point on the line, you could find b. Well, we're going to do the same thing. We're going to find a. And the point I'm going to put in here is this intercept. I know at the point 0, negative 1, that's on the graph. So I'm going to put 0 in for x, negative 1 in for y. So what do I get? This would be 4. So this is written in a weird way this way, but I've got 4a minus 3. So I just put in that point, 0, negative 1. And remember, negative 1's a y. Okay, so I'm solving this. Just sent the negative 3 to the other side. So a is going to be 1/2. You see 2 divided by 4 is 1/2. So I have found that there is a vertical compression here. And my equation is now this. Okay, now that's in standard form, and that would be fine with me, but this asks about general form. So all I would do then is multiply this out. This is x plus 2 squared. So I'd multiply that out. Now I'm going to send this 1/2 through. I don't like this question, especially this early in the discussion, but there we go. They've switched it from standard form into the general form. Okay, so they want us to find the vertex. Now this is the formula that was on the earlier screen. This comes from completing the square, I believe, is how you could find this. I think that's how you derive it. But if you want to find the vertex, so this is the general form of a quadratic, where h is going to be the x-coordinate of the vertex, and k turns out to be the y-coordinate. And so the way you can do that, you can complete the square yourself actually, but what I think is easier is we're just going to remember this formula that h turns out to be negative b over 2a, where that's b and that's a. So we're going to plug that in there, crunch for h, and we're going to get 3 over 2. All right, now that's, so far, that's what we have. Now, how about the k? How would we find that? Well, k is the y-coordinate for the vertex. Well, if this is the x-coordinate, all you got to do is plug it in, and you'd find the value that partners up with 3/2. So I'm plugging that into the equation, crunching it down, and I find k to be 5 over 2. So here's what I've got. I had the x-coordinate of the vertex. I just plugged it back into the original equation to find the y-coordinate. And now, what about the a that sits in front? Well, the a is just this, from like the quadratic, a bx. It was a 2. That was what we had in our original equation. So we have everything we need. That's the a, that's the h, and that's the k. All right, now this is out of order, but what they're saying first is let's put it in the right order. All right, now let's find the standard form. Well, h equals negative b over 2a. So, and the b is negative 6. So negative is part of the formula, so don't miss that. And what's in front of the x squared is a 1. So I've got, this is going to be positive 6 divided by 2. It's going to be 3. All right, now how do we find k? Well, it's the y-coordinate that goes with the h. So I'm going to just plug it in. Okay, so we tidy this up. We'd get negative 9. I'd get 4. So let's build this, the standard form. Now my a is what comes first. There's a 1 in front of there, so it's just 1 x minus the h squared plus k. All right, now the domain and range of a quadratic, this notation looks atrocious, but it's super easy. Let me just talk you through. So the first thing we're going to do is we're going to find that vertex. Okay, same way we did before. You get 9 over 10 as the h. We find the k by just putting 9 over 10 into the original equation. So here's what we got. 9, 10, 61, 20. Now, those are ugly numbers, but that's the vertex. Okay, now, if you remember all the way back to the beginning here, when we did transformations, if I have so a quadratic is either a smiley face or a frown. If I have a negative in front, then it flipped it. It turned it upside down. So this one is upside down with a vertex, is upside down with a vertex at the point 9 over 10, 61, 20. You understand why I say that? Because the a was a negative, it flipped it upside down. All right, now let's do our domain and our range. So if we look for the domain of a quadratic, it's always like we're moving over here. Because of the arrows, it may not look like it, but this extends forever in either direction. So the domain of a quadratic equation is always everything. Okay? It's always everything. Now, how about the range? If we were running our ruler up the y-axis, we would be hitting something everywhere, 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 everywhere until we get right here, which happens to be the value of k. So our range is negative infinity to k every time. Well, I should say it always involves k, but suppose it had gone the other way. Suppose it had been upright, it had been a positive there, and this point was the vertex and it had been 9/10, 61/20. Well, because it was going up, our domain would still be negative infinity to infinity, but our range would have started. So if we were going up, our range would have started at 61/20 and gone up for infinity. So what I'm saying is that k is always involved in the range, but if it's upside down, it's negative infinity to k. If it's smiling, if it's going upright, it would always be k to infinity. All right, let's try this. You can pause it if you want to try it on your own. But I have my vertex, so here's what I know. Because 2 is positive, this is 4/7 and 8/11. So minus 4/7 is moving it to the right, 8/11 is moving it up. So I'm somewhere here. Here's my vertex. Now this is opening up. So now the domain, we're going up the x-axis, it's everywhere. Negative infinity to infinity. And the range is going to go up the line, up the line. It's going to start at k. This is what I was trying to tell you. You'd hit something at 8/11, and you'd go on forever. Okay, we've got a couple more sections here all about quadratics, but that'll end the first part.